right, we've got ubiquinone and other terpenoid quinone biosynthesis here. That's where you make all your respiratory chain coenzymes, like, for example, ubiquinone, coenzyme Q10. In other words, this is why we say, those of us that know how this thing works, that statins are a dangerous mitochondrial poison. They knock down your ability to produce coenzyme Q10. Coenzyme Q10 is vital in the respiratory chain, in the electron transport chain. Without that, it knocks down your ability to produce energy, to undertake antioxidant activity. It can cause rhabdomyolysis in high energy cells like muscle cells. In other words, they can cause muscle cells to die, to break down, to split open, to cause all sorts of issues going on with those. Now, statins are supposed to protect your heart, and your heart is a muscle. So actually, here's a drug that supposedly is protecting your heart from a disease, when actually it's, if anything, it's likely to increase your risk of having heart disease. And at the very least, many people who take statins experience muscle pain, stiffness, things that feel like fibromyalgia, that kind of stuff. And it's because this drug is basically tearing down their ability to produce energy in those muscle cells. Very, very bad, very, very dangerous. You can cause irreversible damage to skeletal muscles, smooth muscles, and indeed cardiac muscles by taking statin drugs. Not good, not good at all. What else have we got on here? We've also got an inability...
Just a question, if that's
yes,
okay.
Please, absolutely, yes.
So whenever they prescribe statins, as far as I know, they usually recommend that you take Q10 with that as a supplement. Yep. How efficient is that in preventing any sort of mitochondrial damage or damage to the ability of making energy?
Unknown. Well, it's unknown, and I'll tell you why. Because as far as I'm aware to date, and I did do a quick search this morning, a cursory search, I was not able to identify any literature where they have identified a transporter anywhere in the human digestive system that can absorb whole coenzyme Q10 as ingested. What happens when you ingest coenzyme Q10? Your body goes, oh, there's a protein, I'm going to split it down into its amino acids. Those amino acids will then be absorbed into my blood, and then my body will use those amino acids to make whatever proteins that it sees fit based on its normal metabolic function. Whoops, it's unable to make coenzyme Q10 because the statin knocks it down. I doubt very much that supplementing with coenzyme Q10 would be remotely effective in ameliorating the very serious risks of damage to your skeletal muscle and indeed your cardiac muscle from taking statins. So that's the answer to that one as I understand it. Cool. If others know more about that than myself and have seen that there are transporters, then please do let us know underneath this video so that I can update my knowledge on that. But as it stands, that seems to be what the situation is there. What else have we got on here? Under the ubiquinones here, the coenzyme, the Q10, all that kind of stuff, all the Qs, not just 10, but all of them actually, 10 being the most important, I suppose. Also down here, that knocks down your ability to produce vitamin K and other clotting cofactors and clotting complement, basically. So, that's another potential problem. Not necessarily a good thing. A lot of the physicians are saying, well, that's great because it means you're less likely to have blood clots, et cetera, et cetera, et cetera. To which, of course, we say, well, instead of knocking down your ability to produce blood clots, why don't we deal with the thing that's causing the disease process in the first place, which is chronic systemic inflammation and not cholesterol in the blood? Anyway, that would be way too logical, I guess, and perhaps not remotely as effective at generating income for companies that produce statin medications and thereby provide physicians with kickbacks and things for prescribing lots and lots of jolly good statins to people.